Welcome back. Okay, so we started implicit differentiation, so let's review a little bit. If we take x squared plus y squared is equal to 36, and we want to differentiate that. When we differentiate x squared, we get 2x plus 2y dy dx is equal to 0. We solve for dy dx, and we get negative y over x. And that's our implicit differentiation. So let's take that to another problem. Let's take that to y is equal to sine of x. Now, let's first find the inverse. When we find an inverse, we switch x and y. Now this is important, so we're going to leave that. And then we solve for y, so we get the inverse sine of x is equal to that function. Good. Now, what happens if we wanted to find f prime? Alright, let's find f prime. Let's go back to this. Let's take this over. So if we have x equals sine of y, which is the inverse, and we differentiate it, we get 1 equals cosine of y, dy dx, which we get dy dx is equal to 1 divided by cosine of y. So that's great. Okay, so that's the derivative. But it's really not in a great form. So let's talk about some things in order to make it into a better form. So let's talk about some Pythagorean rules that we know about sine and cosine. Well, we know the triples. We know, since we have a y here, I'm going to write y, but we know sine of y squared plus cosine of y squared is equal to 1. If we solve for cosine of squared of y, of cosine of y squared, we get 1 minus sine of y squared. And therefore we get cosine of y is equal to the square root of 1 minus sine squared y. And we'll take the positive value because we're dealing with an inverse function, and we know that we are going to run into function domain rules. Alright, so far we replace that, and we're left with the square root of 1 minus sine squared y. Now, last piece we had over here. X equals sine of y. So we can do a little bit of a replacement here, where we get 1 minus x squared. Well, that's a nice form. So it's 1 over the square root of 1 minus x squared is dy dx, which is our derivative. Excellent. So that means that f prime of x for inverse sine is equal to 1 over the square root of 1 minus x squared. Good. Alright, so now you try. We'll do y is equal to cosine of x. Take the derivative, first find the inverse function. So first you can find the inverse. And the second is you're going to find the derivative of the inverse. The way we did it before, where it was an x in your answer. Alright? Good. Try that. Alright, pause the video, do your work, and then unpause it when you're done so you can see my answer. So if y is equal to cosine of x, we know that x is equal to cosine y. And again, we are going to need that later on. So we know that then we have cosine inverse of x is equal to f of x. So that's our inverse function. That's step one done. Now we want to find f prime of x. So we're going to go back to x equals cosine of y. Take the derivative. We get 1 equals negative sine y dy dx, which then gives us dy dx is equal to negative 1 over sine of y. Now remember that same Pythagorean theorem that we used before. We're going to use it again. Oops, sorry about that. So therefore we have sine squared y plus cosine squared y is equal to 1. So sine squared y is equal to 1 minus cosine squared y. So sine squared y is, no square. So sine of y is equal to the square root, again, of 1 minus cosine squared y. So over here, we have negative 1 over the square root of 1 minus cosine squared y. And again, we have this rule of x equals cosine y to do the replacement. And you're done. Perfect. Very nice. Good job. See you tomorrow in class.